Good afternoon, good evening to our viewers. I hope all our viewers are physically and mentally safe and sound during this pandemic. My name is Dr. Chitrini Mozumder. With me is Dr. Sanit Arun Paul at the back end. And on behalf of Remote Sensing and GIS, AIT, I welcome you all to our 5th session of RSGIS webinar series 2. In this session, we have a technical session followed by an interaction session where we will address some issues and questions from our audience. Our speaker today is Mr. Songkorn, who is a PhD student at RSGIS and also the general manager at GEOTALENT company. He has expertise in the field of GIS and worked at GIS company and ESRI Thailand for more than 20 years. Thank you so much, Kun Songkorn, for joining us today and accepting to share your research, your published work with us. I know we all know like you're very busy, but still thank you so much for the time that you gave today. Before we head on to the main presentation, may I request you to please share about your background and your experiences and your current involvement also like in GeoTalent.
Okay. First of all, I would like to say hi to everyone here in this afternoon. Okay. I would like to say that I'm a bit excited to share all of you about my research here. Okay. First of all, I would like to talk a bit about my background. Actually, I studied in geography in Songkorn University many years ago, and then after that, I started my career in ESI Thailand. At that time, it's not ESI. ESI Thailand is not set up yet. When at that time there are about 7 or about 10 people in that section for the GIS in Thailand, and right after that at first I was the technical consultant or technical support for ESI software and RDAS software at that time for both GIS and remote sensing, and after 4 or 5 years of working, I began study my master degrees in computer science in Songkorn University again. It is because when I worked right there at that time, I had to do many things about IT and also the programming. So I just had to learn more about, explore more about the IT world. Then my career is getting bigger and bigger. I mean, I had a lot of responsibility for many projects for both transportation, urban planning, and also the private sector as well. And finally, I felt that it is time for me to explore another academic experience. So I decided to join AIT since 2016, I think. Yeah. So this is my 5th year already. But I still enjoy doing my research together with working in the real life. Okay. So this is my background.
Excellent. And what is GeoTalent and what's your role there?
And for the GeoTalent, this is a company for the which is you can say that GeoTalent is like a software house. You can build and many kind of software by GeoTalent. For example, the web application for both GIS and MIS application, and also the mobile application as well. We have about 50 developers here at GeoTalent.
Excellent.
It is a mid-size of company. Okay.
Okay, thank you. Thank you so much. We're very proud to have you here. So without any delay, may I request you to go for the technical presentation, and then we can discuss more about the technical things later on in the interaction.
Yeah, okay.
Yeah. Thank you so much.
So I just I want to share my screen first. Okay.
Yeah, sure.
So here, actually, I'm glad to be here to share my research on public transport GPS probe and railgate data accessing the pattern of human mobility in Bangkok Metropolitan region. And Dr. Apishon, which is a committee in this committee, one of the member of the committee, and then Dr. Sulache. So this paper was published in February this year. Now I would like uh, to tell you more about my research. This is the agenda. I would like to introduce you about my work and then the data collection and methodology that I use for deriving the human mobility from the big data and the result that I got and the conclusion. And at last, I would like to tell you a bit more about right after I published the paper, what I have done. Okay. So for the introduction, when we're talking about the human mobility, uh, we think about the movement of people from one place to another location. There are many kind of applications for the human mobility. For example, the urban the urban planning, the transportation planning, and and typical pattern or typical form of human mobility will be used the odometrics, just like I shown right here on the right side, that define the origin and the destination and the number of trips or number of people movement from one place to another place like this. So we can use this kind of odometric for many uh, for many applications. For example, when we are talking about the disease spread, just like what we have faced right now of the COVID-19, right? We would like to know uh, how many people move from one place to another place to 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 protect the dispersion of the disease. This is one of the example. So, but when we in the past when they would like to have the human mobility matrix or OD matrix, they have to do what they have to do is to do the survey. This means that they have to uh, send the staff out in the field and then try to ask someone about the question of origin and destination. So the problem is that it's quite expensive and it's quite hard to get more population from the survey. Usually they might got about 1 or 2% of the total population as a sample from the survey. So this is one of the pain that we have to solve. And another thing that if we have one OD matrix and is it not possible for us to create it or to derive it immediately when we use when we want to use it. So so uh, moreover, it is important to have the continuous monitoring of the movement of people or human mobility patterns. So when we talk about the technology right now, we 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 know that a lot of uh, devices, a lot of GPS devices has been attached to the vehicle, and then we can use this data into many kind of applications. And moreover, the according to the regulation of Department of Land Transport or DLT in the Ministry of Transport of Thailand. They just have a regulation that all the taxi, van, and buses must install the GPS tracking system on each vehicle. So that's why we are going to have the more and more data on more and more GPS data flow from these vehicles. And moreover, for the electric rail or metro here in Thailand right now, they got they have the automated fare collection or AFC. This means that when you use your smart card entry to a certain station, your data will be recorded into the system, and then when you travel along the metro lines, and then you use the smart card to exit at a certain station, your trip will be recorded into the system as well. So we think that these two kind of data can be fused together to find out how Bangkokian people and the surrounded provinces people move during the daytime and the nighttime. So this is what is the inspiration of my research. And when we talk about the Bangkok here, you can see on the left side here, this is a Bangkok map, land use map in 2015 from Bangkok Authority Administration. So you can see that at the center of the Bangkok, this is the CBD or Central Business District. So you can see a lot of red colors here, and for the yellow colors, these areas are the residential, and the green ones are the agriculture. So you can see that a lot of people live around here in the east side of Bangkok and the west side of Bangkok as well. So there are a lot of movement of people in the morning when they have to get into the city to work, and then in the evening they have to get back to their home by using the public transport, for example, taxi, van, or subway or metro line. And on the right side here is the map of the metro lines or electric rail lines in Bangkok in 2018. So you can see the BTS in green and MRT in purple and blue, and the airport rail link is in the dark red here. So this is the major public mass transit in Bangkok and the Bangkok Metropolitan region. So when we take a look at the ratio of the public transport in Bangkok Metropolitan region, it is recorded in the Office of Transportation Planning, Transportation Office of Traffic Policy and Planning, in the EBAM. EBAM means Extended Bangkok Urban Model in 2017. It said that in one trip, in one day, there are about 9 million trips from the public transport in Bangkok Metropolitan region. So you can see that 60% is from the buses. So the buses is still the biggest public transport in Bangkok and the adjacent area. And for the taxi and motorcycle taxi is represent about 32% of the public transport. You can see the taxi in yellow and the van in blue colors. So both of them are about 32% of our public transport trips. And for the electric rail is 10% here. So this is the overall picture. And in our study, in my study, I'm interested in two kind of public transport. The first one is a fixed route transport, which is the van and the electric rail or metro lines. And another one is the non-fixed route transport, which is taxi. A taxi is seem like the most comfortable vehicle or service that can serve you from door to door. Okay, let's talk a bit about the data collection. Actually, I have been contacted to a lot of organizations in Thailand to to try to access to their raw data, but finally I've got only taxi GPS data from ITIC. ITIC stands for the Intelligent Traffic Information Center Foundation. So they have the open policy to publish the taxi GPS probe. And I've got the data in the February of 2018. And for the van itself, I have to contact to the Department of Land Transport. In the Department of Land Transport, there is the GPS center right there. That center had to the duty of this center is to collect all the GPS from buses, and the trucks in order to monitor the behavior of the driver. So they got the DLT van GPS. At first, I called them that I would like to ask for the data, and they said that okay, you can send DLT send the GPS center of DLT the letters to request the data. Right after I sent the letter to the DLT, they found that a lot of troubles right there, because one thing that I have been realized later that the system of DLT GPS center can collect the data only 7 days. So that make me that caused a little of problem of my research. You can see that the rest of the data source are in February of 2019, but this one is during the August to September. Only 1 week available here. And these three below trees are the AFC data. So I'm going to discuss a bit more about the data itself later. And finally, I've got the data from the OTP, or the Office of Traffic and Transport and Planning Policy. These are the traffic analysis zones that they use this zone for the forecasting or predicting the traffic volume in the future for Bangkok and the whole country. So when we take a deep look on the raw data of taxi flow, we have the ID, the unique vehicle ID, which is anonymized already. So we don't know what is the the register number of these vehicles anymore. Just they have been processed before I can use it. And we have another significant thing is the latitude and longitude data and the timestamp and the speed and the heading angle and the light status. The light status here is the data that tell you that this vehicle is occupied or vacant. And the last one is the engine active status. So when you the data here will be collected in the SCSV format or comma separated variable data CSV format. So you can see on the left side here. These are the sample of the data. You can see the first one right here. I'm going to change a bit of the pointer here. Okay. The first one is the unique ID of the taxi, and you can see the latitude, longitude, and the date and timestamp here, right here. And this one is really important, which is the light status. Do you in every taxi have the light sign to say that the status is occupied or vacant, right? So when the light status is on, this means that this car is vacant at that time. When the light status is off or zero, this means that the car is occupied by the passenger. So this is the data. So you can see this is the distribution of the GPS code of one day data. And this one is the van data. The van data also have the unique ID right here, unique ID such as 00000 and 0 or 0000 and 1. Again, this ID has been anonymized already. And we have the latitude, longitude, right here. And that's all. And also we have a timestamp here, date time. The date and time here. So they record the movement of the vehicle by using the GPS tracking system installed on the van right here. And the next one, which is the AFC data, which is the OD metrics. But this one is the data that the data that collected by Metropolitan operators, which is raw data, but those raw data are not open for the research. What they open is only the aggregated data. You can see right here, up here. Up here, this is the sample of the airport leveling data. On the row here is the entry or origin, and the column is the exit or destination. And you can say that that is the time right here. Say that it is from 7 to 8 a.m. of the 1st of February. You can see that during 7 to 8 a.m. of the 1st of February, there are about 455 people traveling from Walmart to Payathai. So this is what we got from this data. And below here is the sample of MRT system together with the both blue lines and the purple lines already. Again, you can see this one is the code. I mean the abbreviation of the station. For example, this one is Cultural Center, and this one is around somewhere in the Ramanai. So you can see right here, there are uh, there are few people travel from Ramanai. It's about 28 people from Ramanai to Cultural Center by using the MRT. So this one is a kind of odometrics. And the last one is the TAC. As I say that TAC is a traffic analysis zone. I mean, it's not impossible to do the traffic analysis at very detailed level. So they have to do some kind of aggregation to a zone. There are about 1,800 traffic analysis zone in Bangkok and Metropolitan region that cover 8 provinces, including Bangkok, Nonthaburi, Samut Prakan, Samut Sakhon, Pathum Thani, Ayutthaya, Nakhon Pathom, and Chachoengsao. And moreover, they have the broader zone. We call it the 10 BMR zone that cover each province. And in Bangkok, they divided into 3 parts, which is the western of Bangkok, inner of Bangkok, or central Bangkok, and the east of Bangkok. So these 4 kind of data I'm going to use in my research. And the method or the methodology that I use is I have to load all the raw data into the system, and then I have to extract the OD trips or OD metrics, and then I have to aggregate it, this OD metric into the TAC number to the traffic analysis zone and the 10 BMR areas. And right after that, I have to derive the average morning and evening trips, and then calculate the distance and travel time. In the what I say the morning, which means the traveling between 6 to 10 a.m. and for the evening is from the 4 p.m. to 9 to 8 p.m. And right after this is the step that I use for processing the taxi data. So I have to import it data into the Hadoop Hive first, and then in the Hadoop Hive I have to do some kind of script right there to filter out the vehicle that vehicle that has only the one of live status. So you can say that you can remember that the taxi have to live status with it on and off. So what I did is the vehicle that have both status of on and off of the light, and then have to filter out all the errors. For example, the 0 value of latitude and longitude, 0 value of the timestamp, and finally I sort all of the data by using the timestamp, and then try to find out the origin and destination of each trip by using the status of light and the timestamp. Let me show you in more detail right here. So this is the kind of sample data of the GPS probe of 15 million records, and which is about 4,000 vehicles. And you can see there we have to filter out non-taxi probe and GPS error and longitude of the 0 value, and the some duplication of the data. And finally, I've got the about 10,000 records. And right after I got all the records, I have to check with the light status like this. the red one, which means that that position is occupied by passenger, and the gray one is the vacant status of the vehicle. And then this one is a taxi gesture trajectory that I derived for one taxi. This is another taxi, and this is another taxi. So you can see the red dots here identify that they are the occupied trips, and the gray dots are the vacant trips of the taxi. Somewhere around here. So I have to use this kind of leg of the data to create the trips of the taxi. And what I can do is right after that I can do something like this. Okay, at the starting point, they move from the zone or traffic analysis zone 734 to traffic analysis zone 1728, and then move back to 738, and then move to the 729. And again, the red colors mean that there are some passengers in the taxi, and so on. And finally, I've got the OD data. So this means, for example, this one, this car, which has the right status off, which means that this one is occupied. Then starting from 1 p.m. around 1 p.m. to 1 p.m. and 39 minutes here, from zone 334 to 355. We can display it like this from the starting point to the end point. So these are the OD metrics or OD data of the taxi. And for the van itself, I can do the same procedure, but with another algorithm to derive the trips of the van. What I do derive what the algorithm that I derive the van is I have the assumption of the van must start from the van queue. So all the van in the van queue must stay right there more than 10 minutes with zero speed because they are waiting. And then they have to travel more than 10 kilometers distance. And within the 10 kilometers, they should have more than 20 GPS points. And they have to travel more than 20 minutes move. Just like this. So at the first one, you can see this one have the speed, right? So it determine that these records are the moving, the van are moving here. But unfortunately, it's quite short, less than 10 minutes. So we ignore it. And for this part, we say that, oh, this one, this data, this van just stay on the same location. You can see the latitude, longitude are the same location, and with the zero speed. So it should be and it starting from 6:31 to 6:41, about 10 minutes. So we consider it as this one is in the queue. So they should be in the queue. You can see the location right here. When you take a look at the street view, we found that it is the van queue. And this portion is they move from one place to another place more than 10 minutes. So these are the records of the movement. They move from the queue, travel along the road, and then finally end that here. And this one, again, they have the zero speed of the same latitude, longitude for about 10 minutes, more than 10 minutes. So we identify it. It should be the band queue again. And when we check at the street view, and I found this band queue right there. So we use this algorithm to create the OD matrix of the band, just like this. So the band number 2X9, they have about 100 minutes drive time with the distance of 42 kilometers. They move from zone 1278 to zone 56. So this is how we derive the OD from the band. And finally, we derive the OD from all the metro lines data. Finally, we got they move from the one zone to another zone with number of passengers in the morning and in the evening. So for the taxi, I use the Hadoop Hive to process it, and for the van and the metro lines, I use Java programming to derive the OD, origin and destination records. And this is the result that I've got from my processing. So you can see the cyan colors are van trips, and the yellow colors lines are taxi trip. And the magenta here is the MRT, and the BTS are in green, and the airport links are in red. So you can see that the distribution of the OD of the van is quite broad, quite broader than the taxi. And this is all picture of the morning, weekday morning, and weekday evening. So when you take a look a bit more closer, you can see that this one is the result of my processing of one month average data. There is about 3,223 taxis, and I've got about 2 million trips, and about 49.7% is the occupied trips, and 50% here is vacant trips. And you can see in the morning and the evening and the other period of time, ratios are quite similar between the occupied and vacant trips. And this one is the number of trips based by each hour. So you can see that the number of trips is significantly rises on the in the around 6 a.m. in the morning, and then they just declining at about 10 p.m. in the evening. And for the tube-length distribution, you can see that about 55 or 60% here is in the distance of 1 to 10 kilometers trip of the taxi only. So the rest are the longer trips for both morning and evening. So these are the characteristics of the taxi trips in Bangkok Metropolitan region. And this map shows you the origin, the significant origin and destination in the morning and in the afternoon. The blue map is the origin one, and the orange map are the destination one. But the upper one is the upper maps are the origin and destination in the morning, and the below ones are the origin and destination in the evening. So you can see that the highest volume of the trip origin are from the Dongmueang Airport and the Suvarnabhumi Airport for the taxi in the morning and also in the evening as well. And another interesting is that the area is in the Mega Bangna here, around here, and in the evening also the same location, and the rest locations are the are the uh, are the are the provincial bus terminals. For example, right here is the Mochit bus terminal and also the interchange between the metro lines. And this one is the bus terminal of the southern bus terminal, and this one is the government area, in the middle of the Bangkok. And for this map shows you the OD matrix in the closer view of the 10 area of Bangkok metropolitan area. You can see the highest one is from the Samut Prakan to east of Bangkok. In the evening as well from Samut Prakan to the east of Bangkok. It's quite interesting. And for the van, there's finally I've got about 6,500 vans in the data, and which is about 62% of the van of the register of the van, and total van trip is about 48,000 trips, and there is about 66% of the weekday and 33% of the weekend. And you can see the van trips, the higher volume is in the morning and in the evening. The same window that I mentioned in the morning and the evening travel windows. And the trip length distribution, you can see that the van trip, the highest volume of the van trip is will have the distance more than 10 to 40 kilometers. They occupied about 70% of the trips for both morning and the evening. And here is the distribution of the van trip. For the van trip itself, it's quite interesting that this area, you can see up here is the industrial estate in Ayutthaya, and this one is industrial estate in Chachoengsao. So these two areas is quite important location of origin and destination of the van, and also the center of Bangkok and some part of Nonthaburi as well. You can see right here. So you can see there are a lot of travel from Pathum Thani to east of Bangkok. You can see from this line, and from Nonthaburi to Bangkok as well, to center of the Bangkok. And for the metro characteristic, you can see these two peaks in the morning and in the afternoon of each metro line. And again, for the number of trips, you can see the most highest volume of traveling by metro lines during 1 to 5 kilometers, which is about 42%. Both of which is identical to evening pattern. And then this is the significant origin and destination for the metro lines. They are in the interchange between each line and the and the and also the CBD or the working areas of Bangkok, for example, Silom area or Chitlom area. So you can see a lot of people move from east of Bangkok to the center of Bangkok, and from and quite less from and lesser from the West Bangkok to the center of Bangkok. And finally, I'd like to show you this diagram. We call it the chord diagram. The chord diagram will show you the movement of people. In this case, I use the movement of people for only the one who has inbound and outbound of the inner of Bangkok or the center of Bangkok. You can see down here. At the lower part is the origin, and the upper part is the destination. So this one indicates that a lot of people travel from center of the Bangkok to the other places. The highest one is from center of Bangkok to the east of Bangkok. The second one from center of Bangkok to the west of Bangkok by taxi. And from the inbound side, there are a lot of people. The high volume of people travel from east of Bangkok to center of Bangkok by taxi, and from the west of Bangkok to the center of Bangkok by taxi. And we can see some people travel from Nonthaburi to the center of Bangkok as well. And this one is for the morning, and for the evening it's kind of opposite side of opposite pattern of the morning. And for the van, you can see that a lot of people move from Nonthaburi to inner of Bangkok, and from eastern of Bangkok to the center of Bangkok, and also from Nakhon Pathom and Pathum Thani to the center of Bangkok. And in the evening, this is kind of opposite pattern of the morning. And for the metro lines here, you can see a lot of people move from the east of Bangkok to the inner of Bangkok, and they move from the inner of Bangkok to the east of Bangkok as well. So they are very significant travel between these two, between the east of Bangkok and the inner of Bangkok. And in the conclusion, we found that this map show you some highlight area of the high volume of taxi in the Bangkok metropolitan area, metropolitan region. So you can see that a lot of people need a taxi from here and from Suvarnabhumi and the Mega Bangna. In this case for Suvarnabhumi, there even though there is the metro line from Suvarnabhumi to inner of Bangkok, but it's still the need of taxi from Suvarnabhumi to somewhere else. This means that the mass transit line is not sufficient for the need of the people in Bangkok or the traveler or the traveler who travel into Bangkok. So this one show you the map of the insufficient. So we can use this kind of map for the future plan of public transport in the future. And in conclusion, I would like to say that this methodology technique can be used to process, to transform, to extract the human mobility data from the multiple sources of the big data, and then we can use all the data to if we can use all these big data regularly to derive the human mobility, they're going to be useful for the public transport planning in the future. And currently, we have only 4% of the taxi because ITIC or ITIC collect the data from one taxi operator only. And for the van data itself, as I say, that it's quite hard to get the data from the van because they don't have the open policy yet. So they have, and also they have only 7 days of the data. And for the interchange between the metro lines, we cannot get the interchange information of the metro lines because each smart card of each operator, they are the proprietary data, so they can be integrated together. So we have to wait for the future of the common ticket system of the Ministry of Transport. Right after we have the common ticket system, we can see the real origin and destination from the metro line. And unfortunately, the bus data is not available. I tried to request it from about 6 months, but finally I haven't got it because at that time the BMTA or the Bangkok Mass Transit Authority just set up the system of the GPS system at that time, and it is a kind of rental system from the vendor, and it's not open for the study yet. And I believe that if we can have more big data, more probe, or more AFC data from various kind of public transport, we can have more accurate human mobility data derived from those data, which is good for the transport planning, urban planning, and so on. So this is what I have done for the paper. And I would like to talk a bit about the non-fixed routes and the fixed route relationship. It is one that I have done for a bit for this kind of relationship. Actually, we have 3 kinds of relationship. The first one is competing. The second one is extending. The third one is complementing. The competing, which means that the origin and destination is in the, for example, they take the taxi origin from somewhere around the metro station, and then the station is also the metro station. And for the extending, mean origin or destination, either origin or destination within the area of the bus station of the fixed route station. For example, the metro line station here. So in this case, both B trip and C trip are also the extending. And the last one is the complementing, which means that the mass transit fixed route doesn't cover this area. So origin and destination is out of the fixed route stations. So when we talk about the fixed route station, I use the 200-meter walk distance as the area of the fixed route station. And this is the result of the processing by using the Hadoop Hive to try to figure out the relationship between taxi and the metro line station. So I find that only 1.8% is the competing relationship, and both extending destination and extending origin is about 10%. And you can see the complementing is about 70, 70, 26%. So which indicate that the the mass transit doesn't cover all the area of the Bangkok metropolitan area. And you take a look, a closer look right here. You can see the extending is in yellow of the this means the destination is in the is somewhere around the fixed route station or metro line station, and the extending in green, which means the origin from they take the taxi from the somewhere around the metro line station. And right here is both extending the significant extending for both origin and the destination. You can see the Suvarnabhumi, Mochit, interchange, submit all of interchange and the station right here. So which means that people take the taxi trips to switching between one mode to another mode. In this case, to the metro line station, and this is the highest the this one is the trips of the destination and the origin destination right here, and the extending destination, and the competing and the complementing. So I think I'm going to end my presentation right here because it takes a lot of time here right now.
Thank you so much, Songkorn. Like, this is quite interesting and very extensive work, I must say. A lot of things are going around. So without further delay, let's take up some questions that we have from Zoom and Facebook. How did you generate zone IDs? Are they already predefined or randomly generated?
Do you mean the TAZ zone or the vehicle ID?
I'm not sure. Maybe the participant
To see
can
the chat,
clarify.
right?
Yeah, chat box, please. Yeah.
It's available to download online. Okay, for the first one, the availability of the data, only one source is available online.
Okay.
Is the I think only. For the metro lines data, you have to send the letter directly to the operators to request for the data. And for the van data, you have to send the letter again to the Department of Land Transport. And as I said, it takes a very long time to get the data.
So the long time is like 1 month, 2 months, 6 months, 1 year?
About 4 months for the
Okay.
BTS.
Okay. Okay.
And another one is how can you generate zone IDs? The zone IDs here is, as I say that, when we take a look back right here.
Yeah.
In the slide. This one. So I'm going to
You
share
will
the
share?
slide
Yeah.
again.
Yeah. Share the slide again, please.
Where is the sharing? Okay, right here. Here. So you see the map here. Each block here. Let me change the colors of the pointer here. Each block right here has a predefined number already from the Office of Traffic and Planning Policy Planning, or OTP. So I use this kind of standard zone and the zone ID in my research. So
Okay.
I think
Yeah.
I just answered your
Yeah. So this
question,
is
right?
predefined, basically. Yeah.
Predefined, right?
So we have one more question. I'm interested in Metro data set. How can I access it? Is there any updated data?
For the data itself, I think you can for the open data, the the ITIC itself uh, uploaded this data year by year, so you can check into their website. Okay, I'm going to show you where is it. Please just for a moment. Okay, right here I'm going to show you the URL. I'm going to write into the chat. This is okay.
Yes.
Okay,
You can write in
down
the
here.
chat box. Yeah.
But you have to register, put some fill in some information such as your name and your organization, and then you can access it directly. Now what we have here in ITIC data is the latest one is the December 2020, last year.
So every year it's updated, right? Like
Yes,
kind
right.
of. Yeah. Okay.
But you need to use Hadoop to process it. It's quite big.
Yeah, of course.
You can ask Dr. Apishon for the permission to use Hadoop right there. It's quite good. Yeah. Easy to access and but you have to learn more about the SQL Hive, the SQL language to process it. And also you can use the ESRI Hive library, Hadoop library to process for the special for the special tools such as the overlay, selecting, and the union, something like that within the Hadoop Hive. If you have any questions on those on the Hadoop Hive and the ESI, you can contact me directly. I will tell you how to do it. Okay.
Great. Okay, so I head on to the next question. You mentioned that only 4% of the registered taxis have joined the open path policy
Yes.
to allow the use of GPS probe data, right? So why is it so? Like because you anonymize the data sets, like you don't give the taxi numbers or anything. Then why this like hesitation to share the data?
I mean, in Thailand, I mean, each taxi, right, belong to one operator. There are many operators, maybe 100 operators in Thailand. So
Okay.
there are only few that open this kind of data. So when you one of them is I cannot remember the name, Sahakon something. I can remember the full name, but it's a kind of cooperative right there. That one is open for the ITIC to get the data. You can see the document in the ITIC website about the name of the taxi operator. So I just made the call to the taxi operator and asked them how many taxis that they have during 2018. So when we compare the number of the taxis that register to that operator and the number of taxis in the ITIC data is quite similar. Is it? And and you may have the question that since DLT or Department of Land, land transport, right? Had to collect all the GPS data from taxi, van, and the buses and the truck. Why we don't use the data from DLT GPS center, right? What I can say that I cannot. There is no data recorded in the field in a certain field say that this kind of data is a taxi, and moreover we don't have the light status as well. So if we don't have the light status, we don't know this one is occupied or vacant. Because my research is interested in the occupied trips only. The occupied trips mean that the traveling of the real people from one place to other place. So if we use the data from DMT, we don't know what it is. Okay.
Yeah.
That is why.
Okay.
I mean, at first,
in your work,
I mean, at first time,
go ahead.
I discussed about the taxi data with Dr. Pichon. He said that the best source should be the Toyota to show, but I just sent out the letter to ask for the data, but it's gone with the wind. No answer from them. So I just made a call and no answer again. Just try to find out another source. So finally, I've got the source from the ITIC. So I use this one instead. It's quite. I mean that when you talk about the difficulties in my research, it is the data.
Data accessibility, yeah. That can be.
They are not available for the research. That is the problem.
Yeah. So when you anonymize the collected data, was there any loss of information, and how did you handle it? Like, because you don't give the numbers, right? You do some codes, IDs. So is there a loss of information due to that?
When you see the raw data that I showed you during the presentation, you can see that the data is anonymized already. So we don't know the registration number of the car or the vehicle already. But when I mean for my research, I don't care about the personal data, but I do care about how many people move from one place to other place. So it's fine for me.
So when you get the data, it's already anonymized. Like when they give the data, so they don't give any personal information. So that security is like safe. I mean, the data is the personal information is very safe. Okay.
Even the Metropolitan smart card data, as I told you, is already aggregated into an hour, and from one place to another place, from one station to another station only. So we don't know who they are, who are travel from Phayatay to Suvarnabhumi. We don't know it.
Okay. Is there any more question from the participants? Shishu, Buntang, we have some students who have joined. If not, then we will end this session with a big thank you to Kun Songkorn once again for sharing such a important and interesting research. So we wish you all the best for your final defense and whatever is left.
I hope so. I just I talked to my advisor, Dr. Salavut, and he said that it should be 2 more semesters. The first one to conclude everything, and another one is for the external professor to read all the dissertation. So,
but the hurdle is already gone with analysis and like all the paper publication and everything is well done. So
the hardest one is the hardest one is the paper publication.
Yeah,
it's quite tough one.
Yeah.
So I would like all of the doctoral students to prepare yourself for this one, but it's quite challenging.
Agree. Yeah.
Okay.
But like you, everyone has to pass through all these hurdles.
Yes, I believe that everyone has to pass it. and we'll pass it finally.
Yeah, yeah. So wish you all the best for rest of the study period and all your future endeavors, whatever you are doing. So we are very proud of you, whatever, like you, with your all your experience, and it's very nice of you to, I mean, ask the students to contact you directly if they need something. So
Yep.
I hope the students who are working in the similar research, they will contact you for help.
Or you can send
So
me an
thank you.
email
Yeah,
as well.
yeah,
As
yeah.
my email address is st11874@ait.ac.th. Okay. Okay.
Yeah, yeah. I
Bye
think they
bye,
can find
everyone.
out easily from the secretary. Yeah.
Okay.
Thank you so much. And to our viewers in Facebook, we will let you know about our next session very soon. Thank you for joining us today. This is Chitrini Mozumder again with Dr. Sanit Arun Paul, signing off from AIT RSGIS. Thank you.
Okay. Bye
Thank you.
bye.
Bye.